Chapter 4.2, Solving Inequalities by Adding or Subtracting. So yesterday we started talking about inequalities, and as a quick reminder, we talked about graphing inequalities, how when you have a greater than or less than symbol, you used an open circle on your number line. When you have less than or equal to or greater than or equal to, you used a closed circle on your number line. So why does this matter? Well, if you're going on a field trip, like you all did yesterday, and you want to know how many people can fit on one bus in order to find out how many buses you need, you can use an inequality. So before we get to the real world application, let's take a look here at example 1. Here I have the inequality n minus 10 is greater than 14. We can solve inequalities the exact same way as if it was an equality. So we did this back in chapter 3. Let's say n minus 10 equaled 14. I add 10 to both sides. N equals 24. Using an inequality, it works the exact same way. So I'm going to add 10 to both sides. However, instead of equals, n is going to be greater than 24. So here I've solved it, and now I get to graph it. So I'm going to create my graph. Again, my graph doesn't need to be too big. I tend to like putting the number I have in the middle. Your graph does not need to start at 0. And just for fun, I'm going to count by 2s. As long as you are consistent in your graph of how you can count by 2s, by 5s, by 10s, by 1s, whatever makes your graph make the most sense. Now I know that n is greater than 24, and because it is greater, it is an open circle, and n has to be anything larger than 24. So I'm going to shade in the graph in this direction, getting larger than 24. So these two things are then my answers. Here's my solution, and here is my graph. Okay, let's take a look at example 2. Y plus 7 is greater than or equal to 12. Again, solve and graph. We solve these problems the same way as if they were equations. I'm going to subtract 7 from both sides. Therefore, y is greater than or equal to 5. I create my graph. Y is greater than or equal to, so therefore I'm using a closed circle. And because y is greater than 5, we again head right down the number line. And here is my solution. Here is my graph. And I am finished. So how do we apply this back to that bus problem? So a school bus, in example 3, can safely carry as many as 76 students. If 19 students are already on the bus, how many more can the bus hold? So here we have it in words. I have some students already on the bus. I'm going to add some remaining students, which will be at most 76. So I have 19 students on the bus. I'm going to add some more students. At most, meaning the number can be smaller than 76 or equal to 76, but it cannot be larger than 76. So to solve this, I subtract 19 from both sides. S is therefore less than or equal to 57. So at most, 57 more students can get on the bus. The question does not ask me to graph this, but if I was going to graph it, $57, $58, $59, $56, $55, $50, whoa, $54. Okay, it's 57. It's less than or equal to, so it is a closed circle. But this time it is less than, so we are headed left, this way, down the number line, getting smaller. I don't have to have 57 students get on the bus. I can have 50 or 47 or 32, but I can have no more than 57. Okay, that's it for examples today. Complete the CYU on the top of page 162, and we will go over questions the next time I see you.